Look at those two samples of the code and think whether they are equivalent or not. On one hand, we have an internal class with an explicit internal constructor, and on the other we have the same implementation of an internal class, but this time with a primary constructor. Take a moment and let me know in the comment section what's your opinion. Well, the right answer is it depends. Of course, in both of those cases, if we wanted to actually create a new object of the restaurant.db context type, we'll get an exception, compile time exception, that the restaurant.db context type is not found. So what is the issue and where is the difference? Before we get into the details, make sure to subscribe to the channel. Alright, so let's assume that we have the following setup in our solution. So this is a solution using clean architecture in which we have 4 modules: API, which is a presentation, infrastructure, application, and a domain modules. And of course, we are having the reference from the API to the infrastructure, and inside the API module in the program CS, we are adding the dependencies by invoking the add infrastructure module, which is an extension method inside of the infrastructure module. And here I'm actually registering the restaurant.db context to the dependency injection container. So with this setup, in the case 1, as we had the restaurant.db context as an internal class with an explicit internal constructor, well, we are going to get an exception whenever we are going to run the application, stating that some services are not able to be constructed. And there's an error while validating the service description for the restaurant.db context class. But with the same setup, if this time now we had the second case with an internal class also restaurant.db context, but now using the primary constructor, well, this time everything works just fine. So you might think, what is the difference between the primary constructor solution and the explicit internal one? To solve this mystery, I have prepared a simple proof of concept with my custom dependency injection container. So with the same setup in clean architecture, this time I have created a class that is going to explicitly register type as an interface, and also it has a resolve method that is going to take its generic parameter, on basis of which it's going to actually resolve the concrete instance of a given type. So this is a very basic implementation of the dependency injection container. And let's assume that we are going to actually also invoke the add infra module that is going to register an infra dependency, which is an internal class in the infrastructure module, through a infra dependency public interface. So it's more or less the same situation as we had previously with the restaurant.db context. And this time, in the API module, if you are going to first of all register by invoking the add infra module and then trying to resolve the infra dependency, well, we are going to get an exception stating this time that there is no parameterless constructor defined for the type infradep. Well, even though we really indeed have a parameterless constructor, but it is an internal one. So the reflection that is being used inside of the dependency injection container is not able to construct a concrete type for this infradep type. In the same scenario, but this time with a infradep with a primary constructor, still as an internal class, would work just fine. So now the question arises, why we are actually able to use the primary internal constructors and not the standard internal ones? Well, the solution is pretty simple. Having this class as an internal class with a primary internal constructor, actually the compiler is going to create a constructor that is going to be public anyways. So just because of that, the reflection in C# is going to be able to actually construct a new object of a given type outside of an assembly in which it has been declared. So in our example, for the restaurant.db context class, as it was internal class with a primary constructor, the compiler is going to transpile it to an internal class, but this time with a public constructor that is going to actually pass the parameters down to the base constructor. So the compiler is the solution to our mystery. Let me know in the comment section below if you are going to use this solution in your projects.